Alright, this is the second part of my missile defense project. First off, for my random coordinates and my random distance, I picked my my theta away from my angle away from the origin to be 27 degrees, and I picked my distance to be 750 miles because I changed every inch to equal 1 mile. So you did some trig and figured out that my x distance and y distance, this is going to give me this point with my hypotenuse being 750. And so I have this right here is my graph of, if imagine looking down onto the xy plane and you can imagine the curve right here. This is the equation of my curve kind of coming up out of the screen. That's what we're looking at, and then this line points to my point where my base would be that I'm trying to shoot from to intercept my curve. So what I did is I decided that I want to shoot down the missile at the apex of the curve, and so I took the derivative of the z component of my curve, and I set that equal to 0 to figure out my maximum, and that's what I got, which Maple is confirming right now. And so that allowed me to set a couple points up, knowing that I wanted to go, and here's my graph. Wanted to go from this point to this point, and this is just a vector equation. This is just a line. There's no projectile equation in it at all. And so I set, using what we learned in, what was it, chapter 9 or 10 about parametric vector equations, I was able to just come up with a quick little line. And so that was just me kind of messing around. I didn't really know what I was going to do with that. I was just taking it step by step, saying, okay, well, I know this, I know I can figure out this, I know. And so I actually really struggled with this next part, trying to make it into a projectile equation which goes, up and then back down. But finally I was thinking about it, and if you look at this up down, you can see I was thinking about it, and I said, well, if you think about it, the x equation of, or the x component of the parametric equation of a projectile, it's basically the displacement. You can think about it because it starts at 0, and then whatever points it ends at will be the total distance away. So using some trig, I figured out what this distance was, and I set the x component of my the x component of the projectile equation equal to that, and then for the other aspect of my system of equations, I set the y component equal to where is it at? The height of this point right here, which is right here, the 627. I figured that out when I plugged in my t that I found up here into my curve. So then I was able to figure out my angle of initial launch and my initial velocity. And so, knowing that the x and y components would stay the same because we still want to go from here to here, it's just that we want to have a height difference, I rewrote, and I was able to find my projectile equation. So this part stayed the same as my initial equation that I had up here with the line, and then this part stayed the same as well, but this part I changed, and I found, using that system of equations, I found this to be what I would need for my initial velocity, and then this 43.2 angle was my initial launch angle, pi over 180, obviously, to convert it to radians, minus my gravitational constant. And so this is what I ended up getting, which I was pretty proud of. So you can see it actually has some arc in it, not a lot. You can see that it kind of goes up, and you shoot it, and it kind of starts falling, and it would hopefully intersect. And then, so to figure out where it intersects, I knew that it would hit the curve. To figure out where it intersects, I know that this t, solving up top where I solved for the apex, I know that t was 1.8 where's it at? 1.801. It's up here, right here. So I know that t was 1.801 hours because I converted inches per second to miles per hour. And so, and I made my equation go from here, from one point to the other, from the launch point to the intersection point in 1 hour. I figured that was reasonable. Also, it was just much easier to write the vector equation. So I knew that my difference between the two was 0.801566 and so on. So I knew that you had to whoever launched this second missile would have to wait 0.801 hours, which is, you know, a little bit more than 45 minutes. So I thought it was entirely realistic. So here's a scenario. This missile was launched 45 minutes later. This base right here at this point, this says, oh shoot, the missile got launched, we're gonna have to intercept it. That's probably like right here. And then from this shoots from 0 to 1, and this goes from 0.8 to 1.8, and so then they would intersect. And it took me a while to figure out how to do it in Maple. I knew that from the beginning. I knew what I needed to do mathematically to make them intersect, because this is from 0 to 1 and this is 0 to 1.8, whatever it is. And so I'll bring up my Maple animation. Took me a while, but well, here's what we have. Here's my curve from right here all the way over here. And so let's see, here's what we go when we play it. Okay, and they appear to intersect, but let's see what really happens. So you can see, let's go frame by frame. You can see 0, nothing's happening. As the curve initially starts, this red curve represents the initial missile. So the missile's going, and then as we turn to frame 7, you can see, oh, the blue missile, which is trying to intercept the red one, was just launched. And so entirely plausible and reasonable. Okay, so then to see if they intersect, we just took it frame by frame. We knew that they should intersect approximately when the time is 1.8. So 1.56, they're getting really close. 1.718, they look like they're going to intersect to me. And then as we scoot it forward, they pass each other. And so at 1.87, and their intersection is supposed to be at 1.801. So you can see that they definitely intersect, even though this is not our correct number. If we were to put this to 1.801, it would be intersected. And so I'll play that for you again. You can see it definitely intersects. And again. So yeah, pretty successful, I would say. I think everyone, no one would get killed in this situation. Hopefully, this is what I was talking about with the breeze. If you hit it at the apex, it would spread out over a huge area as it was falling, and not. If you shot it down right here, maybe when you shot it down, the debris wouldn't go that far. It still might land on some people. So, yep, that's it.